Okay, in this video, I'm going to go over the price-dependent regression estimation. Before I start the Excel estimation, I'd like to help you understand what is the equation we are estimating. So the equation we are estimating is actually this is the is we call it price-dependent demand equation. So that's the equation. So on the left-hand side, we have P. So in my regression analysis, I use the real price of chicken as my P. So that's my dependent variable. That's my P. Now I have a F and then as my function, so f would be a function of selected independent variable. Oh, in this case, I have include the per capita consumption of chicken, which is Q self. So now I'm looking at the relationship between my real price of chicken and the per capita consumption of chicken. So my Q is my Q chicken, which is per capita consumption of chicken. I have also included my Q sub 1. This is my per capita consumption of pork in my case. So that's a per capita consumption of your first close substitute. And I have Q sub 2, that's a per capita consumption of your second close substitute. And Q sub 3, that's your per capita consumption of your third substitute. Depending on how many substitute you have, in my case, I had pork, turkey, and beef. You might have Q sub 4. So if you have 4 substitute, you should have Q sub 4 in here. So I'm looking at how this selected explanatory variable or independent variable would affect the change of real price. And I also include a Y in here. This Y is my per capita real income. So that's your real income column. So now my price dependent estimator really is estimating this equation. And if you look at here below the equation, I've also provided you the meaning of each included variables. So let's go to the lower part. The statistical models that I use to estimate my price-dependent equation is listed in here. So the models I use is my P, that's my real price of chicken on the left-hand side, and my beta 0, this is my intercept. My beta 1 is my coefficient for my per capita consumption of chicken. My beta 2 is my estimated coefficient for my per capita consumption of pork variable, and my beta 3 is the coefficient for the per capita consumption of turkey variable, and my beta 4 is my my coefficient for my per capita consumption of beef. And my beta 5 is my coefficient for my real income estimation. Here my ET is my arrow. Okay, so that's my standard arrow. So if you look at the lower part, I have listed the meaning of each of the coefficient to be estimated. I am going to post this handout to Blackboard so you can better understand what we are doing when we are estimating the price-dependent keeper equation. Okay, so in the price-dependent keeper equation, here I have included the year column, the real price of chicken column, the per capita consumption of your chicken column. So this is the real price of your major commodity and your per capita consumption of your major commodity. I have also include my real per capita income column. So that's my third column. I included my per capita consumption of my first substitute, which is pork, my second substitute, which is turkey, and my third substitute, in my case, is beef. So I have included the year, the real price of my major commodity, my per capita consumption of major, and of my 3 substitute. In your case, you might have 4 substitute. And do not forget to include your income, per capita income, as your explanatory variable as well. Okay, so now we have, I need you to prepare this data first, this data column first, and after that we are going to run our first estimation. So what I do is I'm going to go, let's go drag up, go to data, choose data analysis, pick regression, click OK. So I'm going to first of all select my input Y range, and my input Y range is going to be my real price of chicken column. So I'm including my real price of chicken title and all the numbers in this column. So that is my dependent variable. That's a C column, including the title and the numbers. And my X variable, that's my explanatory variable. I'm going to include my per capita consumption of chicken, real per capita income, per capita consumption of pork, per capita consumption of turkey, and per capita consumption of beef. And I'm just going to drag it down. So it will include all the numbers in this column. So let's just show you here that I have included all the numbers and the title of those columns. Here I'm going to click output range. See here, I'm going to click here. So I require Excel to print out my output in this, start from this box. Okay, so I'm going to click OK, because I've already have something there, and the software asked me if I wanted to override the existing data. I'm going to click OK. So this is my estimated model for the price dependent keeper equation, and let's take a look at the result. So first of all, I'm going to check my R-square. The criteria is 80%, and I found out my R-square is about 50%, which is lower than 80%. So I need to move to my next criteria, which is my F value, and I want my F to be at least 5, and I only have 4.47, so I need to go check my next statistics, which is the significance of F. Okay, so if I look at my significance of F, I got it a lot lower than 10%, because 10% is my criteria, right? I got 0.005, which is less than 0.1. So that means my model is meaningful. So I can go to the lower part to explain my coefficient. So what I do is I always wanted to look at my t-stat and my p-value first. So let's just quickly highlight, go to home, go to this. So I can just highlight my T and P values in here. So if you look at my estimation, you find out my per capita consumption of chicken, which is which has a high t value, I want my t value, the absolute value of t, to be above 2. So in this case, my absolute value is 3.43, which is bigger than 2. And I want my p-value to be less than 10%. In this case, my number is a lot less than 10%. It's a lot lower. So my per capita consumption of chicken has a significant and negative relationship with the price of chicken. So because it is a significant variable, I am just going to highlight this estimation. Okay, so let's look at my next explanatory variable. In this case is real per capita income. And if you look at my t-stat and my p-value, you can find out this real per capita income has a high t, which is bigger than 2, and low p, which is smaller than 10%. So again, I'm going to highlight this row. That means my real per capita income is significant in explaining the change of my real price of chicken. And now let's look at the rest of 3 variables I included. Those are per capita consumption of close substitute. I got a low t, which is much smaller than 2, and a high p, which is much bigger than 10%. For my per capita consumption of pork variable, that means this variable is not significant in explaining the change of real price of chicken. I also has a very the absolute value of t is very low for per capita consumption of turkey, and a high p value. Again, a low t stat and high p value, which means the 3 variable, I mean the per capita consumption of real substitute of close substitute, are not providing additional information to explain my per capita to explain my real price change of chicken. So in this case, I can conclude per capita of consumption of chicken does explain the change of real price of chicken, and the real per capita income does explain the change of real price of chicken. So let's look at the impact of the first variable, that's per capita consumption of chicken. We found out a negative sign in here. So that means the per capita consumption of chicken has a negative relationship with the real price change of chicken. And the magnitude of this impact is about 3 cents. So that means when per capita consumption of chicken goes up by 1 pound, pound is our unit, the real price of chicken, I mean acceptance or price willingness to pay for real price of chicken would drop by 2.9 cents because our dependent variable is in dollar sign. So that's how we interpret this coefficient. Okay, let's look at this coefficient estimate for the real income. So real income, first of all, has a positive impact on the price change of chicken. So we have a positive coefficient estimation in here. Well, but this number is very small. It's like 0.00095 because it has e negative 0.5, so it's like a very small number. That means the income change does have a statistically significant impact on the price willingness to pay for chicken, but the impact is very small, it's close to 0, which is very consistent with the theory we learned in chapter 1. We found out in chapter 1 that consumers' income change does not have a great impact on their price willingness to pay for food product. So that's our first estimation for price-dependent equation. In the next video, we're going to continue the price-dependent equation. Thank you.